Hey there and welcome back to the Code Wrinkles channel for this brand new video. The concepts of entities and value objects are another core principle of domain-driven design. And I dare to even bluntly say that if you don't design your classes, your domain classes in terms of entities and value objects, then you are not doing DDD. That's why in this video we'll explain what entities are, what value objects are, and how do we implement them practically in our .NET applications. Stay tuned as you're about to discover a lot of practical stuff. Entities and value objects are conceptually very different. Talking about entities first, I would like to take a short plunge into philosophy because I really think it would help us settle the concept better. So there was an ancient Greek philosopher called Heraclitus. Now, even though few people heard about him, there is actually a very famous quote that is attributed to him, and this quote is, "You never cross the same river twice." This is intended to indicate that the river constantly changes as the water flows. His core idea was that everything changes from one instant to the other. So if we talk in terms of the river that we cross, we need to be able to identify it first. Because if I cross the Danube now and the Mississippi a few days later, it's for sure not the same river. But if I cross the Danube now and then in a few days again, it's not the same as the water I passed through the first time is already long ago in the Black Sea. Now, taking this back to the programming and to an example that might be a little bit more familiar to us, like for instance, the product. Now, a product that we have right now, we created for the first time in our application. Now, that product will change over time. It will have probably a different price at a certain point. You might want to change the name because you might want to adjust for CEO or something like that. You might even want to change the description. So the product itself, you can see that it is changing. It is constantly evolving, even though in the database and conceptually in our application, it's still the same product. So that's why we actually need a way to identify, or we need this identifier as a thread of continuity so that we know all the states through which a certain product or a certain, entity has passed throughout the lifetime of the application. When talking about value objects, we don't really care about state changes, we just care about a certain value. And let me also give you a practical example about that. So recently I was in a city break in Budapest in Hungary. And for instance, right now I have in my hand this 1000 forint bill, which is the Hungarian currency. Now I can safely say that I have right now in my hand 1000 forint. Cool. Now, if I put this bill down and I actually take another one, I still have 1000 forint, even though the bills are different. So here it's the first, here is the second. So you get the idea. We don't really care about the entire history of the bill, which bank has released it. I don't know who other owned that bill at a certain point. I don't, or I just care that I have 1000 forint. So I'm really interested about that specific value. And that's what a value object is all about, like a value snapshot that kind of like is self-explanatory in itself, and it doesn't really need any other additional information, and we don't really need to track a history or changes for that purpose. Now, of course, things can get a little bit more difficult or more complex because depending on the domain for which we are building a system, a certain idea or a certain concept or a certain class might be an entity in one domain, but it might be a value object in the other domain. So for instance, if we go for the same example that I had here with the bill, if I'm building a system that kind of like wants to track bills and how they flow throughout the economy, then our bill will surely be an entity because we would be interested in the serial number of each bill and kind of like identify exactly all the history of the specific bill. But if I have an e-shop and I just want to sell products and maybe I receive cash, let's say, I don't really care about that. So in that case, the price, for instance, might be a value object. When we think in terms of the product, we said once again, okay, we can have the price that could be a value object, but the product itself might have a height, it might have a weight, and it might also belong to one or more categories. Now, I don't really care about the evolution of categories. I just care about the category to which a product belongs. So this means that the product or that the category for my product is also, in our case, a value object. Now that we have actually put this aside, let's go over to Rider and try to see how we can actually implement these two types of entities and value objects in our .NET Core applications, or in other words, how do we design our classes around these concepts of entities and value objects. So here we are right in our DDD solution that we have used for the video on bounded context. So if you're not sure about why we have this structure here, you will find a link to that video in the description of this one, and also a link in the corner up right now on this video. So you might go and watch it a little bit later to understand all the concepts or why we have actually split everything like this. Now, right now we are in this catalog bounded context and we have this concept of product. Now, the product from the standpoint of domain-driven design in this case is for sure an entity, because as we briefly discussed during a description or explanation about what an entity is, the product is something that we have and that actually will have probably a lot of different state changes, and we want to be aware and know exactly that product X had some changes basically, or something changed for the product X, but it still remains the same product, like from an identifier perspective. So that's for sure an entity, and that's pretty clear. However, if we look at this other property that we have here, this list of product category. Now, if we look at that, we see that this product category class is actually just something that we have created because we know probably that if we are using entity framework core and conventions, this is how we would model a many-to-many relationship. And that's a really first key learning point in this video, is that when we design our classes in our domain, we should not care about entity framework core, about persistence, and we shouldn't care about anything else except the class itself. And when we think in terms, once again, of our domain model, we need to design our classes in terms of entity and value objects. So everything in our domain model should probably be an entity or a value object. Now, this means that this entire product category class is actually something that we don't need and that we really don't want to see when it comes to domain-driven design and the concept of value objects. And we see that the many-to-many relationship is actually between product and category. And here we have this category, which also has a name and a description. Now, in this case of the category, we don't really care about the thread of continuity. We just care about these two values, like the name of the category and probably also the category description, and that's it. So this means that the category is probably a value object. So this means that we will have to kind of like refactor right now our product so that the product itself is an entity, but then the category is actually a value object, and then my entity would have a list of categories, like a list of value objects right here. So let's start by doing this, but before we actually get to kind of like refactor the existing code, we need to kind of like define what an entity and what a value object is from C# and .NET perspective. So this means that what I would like to do is I would like to create some base classes for entity and a base class for value object. Now, to do this in domain-driven design, there is another very important concept that Eric Evans in his book talks a lot about, and this is the concept of the shared kernel. Now, in each application or all the systems that we will write, we will need, or we will have probably some base types or some, well, classes that kind of like will be reused throughout all the bounded contexts that are maybe not really 100%, let's say, bounded context specific. And for that case, we can then actually just add the shared kernel. So we can add here a new solution folder, and we'll call this shared kernel. We use the naming that Eric Evans proposes in his first ever domain-driven design book. You might find exactly the same concept also in different namings, like maybe some common folder or things similar to that. So that we have this shared kernel solution folder, let's now add also a project to this solution folder, and this would be a class library, and we'll call this just shared kernel. Let's start by creating an abstract class for the entity. So we'll add a new class and we'll call this entity. Now this will be a class, and we will make actually a generic one, because in our entities, we might want to support different types of identifiers, like we might have an integers, we might have longs, or we might have GUIDs. So it would be an entity of TID, like this would be the identifier, And the only thing that we want to actually add here is the implementation of a certain interface. But before I do this, I actually want to kind of like, drill down to what exactly the main difference is between an entity and a value object when it comes to the .NET implementation, or when it comes generally to their implementation in a programming language. And the main thing is, or actually there are two things that are kind of like totally different conceptually. Like first of one is equality. So how do we actually check for equality? In case of an entity, of course, we will want to check the equality based on the identifier, and we don't really care about anything else. And when it comes to value objects, we want to check the equality based on the values itself. Now, or this kind of like would be the structural equality. So this means that I would like to implement here I equatable of entity of TID, like that. Cool. So now I have this base class, and of course I would have to specify the implementation for the IEquatable, and I have already prepared something here, and we'll walk through this code very, very quickly to understand exactly what we do. First of all, we have here a constructor, and in the constructor, we want to check first the type of the identifier. So if the identifier is actually not an integer, not a long, or an entity, or a GUID, then we kind of like return this exception. And we see that kind of like this is a reference to this private method that is valid, and we check exactly that. Now, if we go a little bit further, we see that we get the identifier, like the ID here, directly into the constructor, and we of course set it to our ID field. And then we have the implementations that kind of like make this entity be really an entity from a domain-driven design perspective. Now, first of all, this is an override to the object equals method, and this override kind of like actually uses this implementation of IEquatable, like the equals from IEquatable, and we see that, okay, what we want is we want to kind of like just compare the identifiers. So we see that we compare those identifiers, in this case based on the hash code, but you could also simply use just the identifier, so that wouldn't be a problem. And by the way, please take this code just as a reference to understand what exactly, an entity is and what exactly a value object is. But when you work on your projects, you might want to define equality, maybe a little bit differently, especially when it comes to value objects. So you can take this really as a template, as a think through, but also don't really waste don't hesitate to actually invest any time in understanding if maybe in your specific projects you would need to tweak this a little bit around so that it corresponds to your specific requirements. Cool. Now we have this get hash code method that we also have to implement. Like, this is a best practice when you implement the IEquatable. You should also override the get hash code method to kind of like be sure that your equality check is basically in symphony with your get hash code method. Otherwise, you might get some weird results. Now, then another best practice is when we implement IEquatable is to also override the equals and the not equals operators, and that's exactly what we do here. And basically, that's kind of like it for the entity. So it's really not complicated at all. It's just this entire concept that when we check for equality, the only thing that we care about when we talk about entities is that the identifier is the same. Now, let's also implement the value object base class. So let's add a new class here, and we'll call this class value object. And let's also make it abstract. So it would be public abstract class value object. And what we'll do here is also we'll implement the IEquatable of value object interface. And of course, also here I have already prepared an implementation, and that's an implementation that's kind of like also based on one of Jimmy Bogart's implementations of a value object that's kind of like, I don't know, maybe from 2010 or something like that. but I have adjusted it for this or for the purpose of this demo just a little bit. Once again, you can take this as a baseline, but when you go to develop an application, maybe even your side project, give a little bit more thought if you want to tweak this around, because you might want to think about how do you want to implement equality actually a little bit differently than I do, and that would be totally fine. So what we have here is we have this protected abstract method that returns an enumerable of object, and we call this get atomic values. And this method will actually be very, very important because we will need to kind of like implement this method in all our value objects, because this is actually how we understand, or how will we know in all value objects that we will have in our application, um, how, if they are equal or not, or which properties or which information should we take into consideration from also for the equality comparison or not. And then if we do this implementation of equals from the IEquatable interface, here of course if the type doesn't match, then we just return false, and then we just get the enumerator for these values and for the others values, like from the two different objects or value objects that we want to compare one with the other. Now, what we do here is we use this move next functionality of the enumerator, which will return us a true or false if a next move was possible. And if a next move was possible, we just make sure that first of all, they are not null. So if in this case, in this specific implementation of the equality, if two value objects are null, we'll consider equality as false, because we don't really care about nulls. We just want to kind of like take compare values, and only if all the values or all the properties of the value objects match, only in that case we want to actually return true. And this is actually what we do here. And last but not least is that actually if we actually arrive here, it means that, well, all the properties were actually equal, because otherwise we would have returned already false. And by the time we reach this code, the move next will return false, because there won't be any further next move possible, so it will return false. So in this case, we just return the negations of this values move next and the negation of the other values move next. And what we do here, of course, once again, the best practice is when overriding or when implementing the IEquatable interface, we just use this override for the object equals method that kind of like will just reuse this other method that we have just defined here based on this get atomic values, which once again is crucial. And then we have the implementation of the get hash code. And once again, in the get hash code, we select all the properties of the value objects that are basically not null, and then we do a simple aggregation, and then we do actually a bitwise exclusive or operation here on x and y that would return us a very nice hash code. And if the two objects that we compare are actually equal, like they have the very same properties, this result will always be the same. And then once again, as it is a best practice, we override this equals operator, and we override or we define the not equals operator for what actually this value object is. Now that we have implemented these base classes right now for entity and for value object, let's go back to our product catalog, like to our bounded context in this catalog, and let's go and implement or turn these classes that we have here, our domain models, into entities or value objects. To make this product class an entity, we just need to kind of like inherit basically our base class, which is an entity of integer. Now, the only problem is that in our entity base class, we have defined a constructor that kind of like takes in an integer to do the validation. So what we'll do here in this case, we'll create here a constructor. Now, of course, we don't really need everything here. Let's just remove things that we have here. We just need the identifier. So that's the only thing that we need. And that's it. So we have now created it, and we use this constructor, and we pass this to the base class, which is our entity abstract class, and we are good to go. Right now, our product is, from the point of view of domain-driven design, an entity, because it implements, or because we have implemented this entity class that kind of like checks the equality based on the identifier and doesn't really care about anything else. Cool. Now that we have this entity, let's go back to this concept of value object. And we have said that this category is a really prime candidate to be a value object. So in this case, also the only thing that we need to do is we want actually to implement value object here, or inherit value objects. Sorry for that. And here, of course, we want to implement the missing members. And that's actually very, very important. Now, first of all, what we want to do here is we kind of like say that we don't want an identifier, because the only thing that we care about right now is just the category name and the category description. And we don't really care about this list of product category, because this is something that we have just used to implement a many-to-many relationship. And once again, when we design our domain classes, our domain model, we shouldn't really care in the design of our classes about persistence and other well, things that are outside of the domain. So that's totally forbidden when it comes to domain-driven design. Now, the only thing is that we have to kind of like implement these get atomic values. And the implementation for this one is actually very simple. So when I compare two categories to actually check if they are equal, first of all, I would like to check the category name and then description. And this is what actually my base class will now use actually to compare the equality, because this is this is why we have actually defined this get atomic values method that is abstract and it should be implemented by all value objects, so that our base class does exactly know how to actually compute or define the equality. And that's exactly how we did it. And actually, that's it right now. So we have also implemented this value object, and our category right now is a value object. Now let's go back to the product instead. And here, to make everything according to domain-driven design, there is one last change that we want to do here, and this is this product category list, which actually we don't really need anymore. What we need instead is a list of public list of category. So that's really everything that we need here. Let's call it categories, and it would be the new, and that would be it. However, this is right now, let's say, a domain-driven design compliant implementation or domain-driven design compliant .NET implementation of the concepts of entity and value object. However, I have to tell you that working with value objects especially is very tricky and difficult in .NET, and it comes actually with a lot of things that we need to think about. And yeah, I have said earlier that when we design our domain model, our domain classes, we don't really need to care about persistence or entity framework core or anything else that's kind of like outside our domain model. However, if we think a little bit further down in our application, we will soon see that, okay, right now our domain is fully compliant, kind of like with this concept of value objects or entities. But when we will want to implement persistence, well, we won't be able to kind of like actually do this in the form that we have right now. And there are some challenges why we can't actually do this. And the first challenge is that, first of all, we don't have an identifier here. And as we know, entity framework will or might want to have an identifier so that it knows exactly, well, what actually the primary key of a certain entity is and how it should be actually stored in the database. So that's a first problem that we'll have. And the second problem that we'll have is that here we have kind of like this, well, one-to-many relationship, and here we have this just list of category. So this will not be able, or we will not be able to kind of like implement this as a many-to-many based directly here on the domain model. And as these challenges are very important in this video, I really wanted just to make you aware of them, because I will create a video dedicated on how we persist value objects in the database using Entity Framework Core. And I will cover different strategies that we can actually use, show the pros and cons for each of the strategies, and well, give you at least some options about how you or on how you can go about the challenges that you might have when you want to work with value objects in your .NET applications. However, before we wrap up this video, I want to come back to this idea of value object one more time, because we have implemented this abstract base class, which is the value object. And in this abstract base class, we have done a lot of things. And mainly what we have done is implemented equality, searching for structural equality. Like structural equality means when two objects basically have the exact same attributes or the exact same properties. Like this means structural equality. Now, starting with C# 8, we have this new addition of records. And records are actually very, very nice because records implement structural equality right from the get-go. And more than that, it doesn't, or records don't really just implement structural equality, they also implement this concept of immutability. And I said a little bit earlier that when it comes to value objects, the idea of immutability is very important. Because if we think about this category, we shouldn't be able to actually set anything to this category. So we shouldn't even be able to maybe have a setter here. We might just initialize some values in the constructor. But for the sake of this demo right now in this video, I will just make the setters private. Because what we'll want to do here is to do it like this. Now, implementing this idea of immutability would mean that we should implement kind of like methods, for instance, if we want to change the category name. So it would be something like public, it would return a new category, and then we should just have here a string for the category name, a new name, and what we'll do is we'll just return a new category, and here we'll have category name equals the new name, and then the category description, it would be equal to the already existing category description. So this means actually, or this is how we should implement theoretically immutability. Now, if we do it as a class, like we have done it right now, each LU object should have something like that. But records, actually, they are very helpful because they also implement immutability. So if we want to change something in a record, we can just simply do that by providing, for instance, the with keyword, and we just change a certain property. But what happens actually under the hood is that we always get a new record back. So we don't change actually the state of the instance, we just get a new instance with the desired state. So this is really kind of like very similar to how strings works in C#. And coming back to this idea of records is that what we can do here is for our value object or for our category, of course, now we would have to, here we need a semicolon and everything would be fine here. But the other way that we can actually think about value objects starting with C# 8 is actually making them a record. So instead of having this class, we will have this a record. And in that case, we don't really need to inherit anymore from this value object. And in this case, we wouldn't even need this method anymore. And we wouldn't even need this method anymore because equality actually in records is already structural equality. So it checks under the hood that the properties kind of like match. And in that case, it returns us true if we check for equality. So bottom line is that what I wanted to do here in this video, I wanted to kind of like show you the thought process on how actually a value object should behave. And if you want to go, let's say, the pre-C# 8 version of working with value objects in .NET, then you would have to always have something like a base class for the value object that implements IEquatable, where you kind of like, well, implement your concept of structural equality for your objects, maybe with something like a method with like get atomic values, and then all the implementations for the IEquatable part. And then you would have to go to the each value object and kind of like implement methods that return always new instances when you want to change something, like when we want to change the category name and category description. So what we can see here is that using this concept of record or records have simplified a lot the way that we can actually implement value objects in our .NET applications. This being said, however, the challenges that I have mentioned earlier, they are still here because they are still the same. If we want to implement this with Entity Framework Core, we would still need an identifier, and we still don't really have a very good way in implementing a relationship here, because kind of like having a property, something like list of product category, that is not domain-driven design compliant, because this concept of product category, that's just a POGO class that we use actually to represent the joining table that Entity Framework Core or that SQL needs in order to create a many-to-many relationship. So once again, I will create a dedicated video on how we work with value objects when it comes to persisting them in the database or in an SQL database using Entity Framework Core. But till now, if you think that this video was useful, please subscribe, hit the thumbs up button, hit the notification bell button if you want to get actually notified whenever something new happens here on the channel. And usually or there are a lot of things happening here, like 2 videos a week, also a live stream a week. So there are plenty of opportunities to kind of like get in contact with some stuff that we produce here. But if you think that there might be others interested in this type of content and you think that it might be useful for them, don't be shy and share it. Maybe with your peers, with your friends, on your social networks, on forums, wherever you think that there might be somebody that would be interested and would benefit from this content, just share it and I am sure that they will be thankful. This being said, once again, thank you very much for watching, and until the next time, I wish you the very best.